Our concept centers largely around the use of water tanks as walls, essentially forming a water wall. While the benefits of having a water wall are far-ranging, our project focuses specifically on its thermal benefits. While there are many ways to passively cool a space, we will focus on the use of a thermal mass. In layman terms, the mechanics of such a system involves using a thermal mass to store the coolness of a night for use during the day. This system has to be coupled with a climate-responsive architectural design that exercises all the strategies that will provide the most optimum condition for water walls to work. This includes the proper orientation of the plan, such that the water walls are shaded from the sun path, thus ensuring cross-ventilation across its surface. Thermal mass describes a material's capacity to absorb, store, and release heat. The factors affecting the effectiveness of a thermal mass are specifically its heat capacity, its thermal conductivity, as well as its material's density. Water, having a higher heat capacity than brick as well as concrete, makes it a suitable material for thermal mass. It is also considerably cheaper and is a good noise insulator. To test the effectiveness of such a system in Singapore, we set up an experiment consisting of two scale models, the first being a control model of a normal concrete box, as compared to the second being that of an identical space with one of its walls replaced with a water wall. We can see that the water wall was able to cool down the space a lot quicker at night, while retaining some of that coolness during the day, resulting in a cooler indoor temperature. So now let's look at a typical HDB layout. As we can see, most walls have direct exposure to the environment, but some can be internally shaded from the sun. So now let's cut a section. The lift core creates a negative pressure that allows cross-ventilation to occur, further cooling down the shaded internal walls, hence making this the most suitable place for a water wall. The water wall is able to retain its coolness at night and provide radiant cooling during the day, making the internal spaces more comfortable as well as reducing cooling loads on the building, thus saving electricity. With the water walls come different possibilities in water management systems, such as water retention, which reduces the chances of flooding. So remember, with water walls come great possibilities.